Hello and welcome to a new conversation about software engineering. Today with Christoph Windheuser. It's actually not a conversation about software engineering, but more about data architecture. So before I welcome our guest, we are still the three of us. Sven, Heinrich, how are you doing?
Great. Good to be here.
Good. Alex, how are you doing?
I'm still fine. End of the week. It's great.
Yeah. Nice weather. That's true. Today, I'm really excited to have our guest Christoph Windheuser. He has a multiple decades, 30 plus years career in data. Right now, he is at Databricks. He was head of data and AI at a global consultancy called ThoughtWorks. Basically being at ThoughtWorks and Databricks should be enough, yeah. But I think there were a lot of other interesting parts of his career, being at SAP, for example. But also, you were in France, in Paris, doing your PhD back in the days when all those, big guys like Jan LeCun and stuff like that. You did your PhD in artificial intelligence, right?
Yeah, this is right. So thanks, Sven, Heinrich, and Alex, to having me in the show. I'm very, very happy to be here and talk to you. That's great. And Sven, you are right. That was an interesting experience. You see, I'm a little bit older, so I have up to 30 years of experience in the industry. And I did actually my PhD that was with France Telecom in 1995. And at that time, already in machine learning. And we worked with neural networks. That was the name at that point in time. It was not really deep learning because the networks haven't been deep, but it was exactly the same principle. It was gradient descent. It was back propagation. So the same mathematics as you have today up to the transformers, same mathematics behind. And we could show it's working, actually. What was obviously lacking at that time was on the one side, the data. We had tiny little databases. So for speech recognition, for example, we recorded the speech by ourselves, cut it into single words or digits. And of course, the architecture of the network and the hardware behind it was much more limited. So we could run, 1, 2, 3 layers. That was the maximum. Not only because of the hardware, but also because of the training data. If you don't have that many training data, you cannot train a model with a huge number of parameters, right? But it was working. And France Telecom was really interested in this, to use this for digit recognition, dialing, and this kind of stuff. And it was an amazing time. And Jan LeCun and all these guys have been already around there doing their PhD, AT&T Bell Labs and other places. And we met in conferences. NeurIPS already existed at that time. And it was very exciting.
Cool. All right. Before we start, I think Heinrich had a question on the piano, did you?
Yeah, I really like the background, and I was just curious about your take on Chopin versus Tchaikovsky.
And by the way, this is a real background. It's not virtual, so you're right. And I'm very lucky one because I'm of the few people who actually has a grand piano in his office.
Nice.
So that's great. But I have to disappoint you a bit, Heinrich. I'm not playing Chopin or Tchaikovsky or no anymore. But I'm playing jazz. I love jazz music and jazz piano. I also play here in Cologne, where I live in a band, so you can see me live sometimes. And that is something I do when I'm not working on big data architectures.
Any favorite jazz composers that you like to play?
Well, my favorite jazz pianist actually is Bill Evans. I think he's the greatest. Oscar Peterson is also great, but these are huge people. You will never achieve that. But we are playing the standards in the real book, and of course the Miles Davis stuff, Kind of Blue. Probably a lot of people know this album. So that's just amazing music.
Nice. And it's so great to have it like in the picture, It kind of sets the tone, it sets the atmosphere, and a big music fan myself, and sadly not so active at the moment, but really appreciate that. Yeah.
Do you use it?
You should do this, Heinrich.
Yeah.
Do you use it between, like meetings to relax, to decouple?
Not really. I think it would be a good idea, right? But what really happens when I have my calls with my colleagues at Databricks or so, and they say, "Oh, you have the piano. Can you play?" And sometimes, when we have a little bit of time, I just play for them. That happens actually.
Nice.
Cool. I hope nobody tries to join in because of the latency. It's usually, everyone knows this cringe moments when people try to sing in harmony over Microsoft Teams or something.
Actually, that's very difficult. And, during the pandemic, we tried to practice rehearsal with our band remotely. But as you said, with the latency and jazz is very rhythmic music, of course, that didn't really work well.
Yeah.
All right, wonderful. Let's start with the data architecture, I would say. There are three modern types of data architecture: data lake, data lakehouse, and data mesh. We want to talk about those. Mm-hmm. But first, before we start, I'm also not that young anymore. And when I started with data architecture, there was the good old data warehouse where, I happily created materialized views for ETL processes to pick my data up. So what is actually a data warehouse, and why did it become unpopular in the last 15 years?
Or why did it become popular in the first place, right?
It became popular and then maybe not popular any longer. I think it's a great question, Sven. And probably younger people among us don't have been living at that time or don't remember. But it started all, with the ERP systems. At that time, I worked for SAP, and these were very transactional systems, and they had some kind of reporting. Like the reporting you have today is SQL reporting in a transactional database. But these reports are very limited. And what the companies like SAP and Oracle, Terraform wanted to offer, and the customer really wanted to have, is some analytics workload and really doing this kind of slicing and dicing, what a data analyst is doing. So going into the data, show me all the sales results of this region or of this product group or of this sales organization or whatever it is. And this is a very different requirement than transactional listings or reporting, because it's more real time. The analyst goes there, and actually you need access to a huge amount of data, and then you slice and dice and have to select out of that data. And the problem is, this is a very different requirement to the database. Transactional databases, and today we call them OLTP, so online transactional processing. They are built to make lots of transactions more or less at the same time or in very short notice, so that they block maybe a row in a database, make the update, and then free it again as soon as possible so that the next transaction can go. Imagine flight booking systems. That's a very good example for this, right? But when you do analytics, you want to have access on a huge amount of data, and then you read. Actually, you are not updating, you are just reading, but big amounts, and you take it out of the database, then you make a selection on that. So this is a smaller part and another selection, but then you go back and read again. So it's a completely different workload. And it was very clear that the transactional databases at that point in time were not made to do this with good performance. It was not working. And therefore, they developed another architecture, which was optimized to this kind of workload. And they called this the online analytics processing, OLAP, right?
Yeah, the OLAP cubes.
Exactly. And that was the cubes, big cubes you can read, and then you can slice and dice along of dimensions through these cubes, get data out of it, and then present it in some graphical way. And actually, that was a lot of workload on these machines. And therefore, some special hardware was required, so that the memory, the storage had to be very close to the processing. And these machines were really on-prem at that point in time, obviously very expensive. And you could not really scale. The only thing to scale is just to buy a bigger machine. And Alex, maybe you know this of history in your companies, these were these huge machines in the basement, super, super expensive for these business warehouses, right? They still are there with a lot of customers today. But that
Oracle Exadata, it was for me back then.
You remember, right? And that was then, I mean, they worked great for this point in time, but that was also the disadvantage. They were not able to scale, very, very expensive, usually on-prem, CPU storage was very close to speed up the processing. But at some point you had the biggest machine already in your basement. You couldn't scale up even more. And that was a big problem. And then, of course, and then we are here in our topic, cloud came up, right? A couple of 10 of years ago. And of course, the cloud infrastructure changed the whole picture. And what also changed is that new processing schemes, massive parallel processing were developed. This all started with Hadoop at Google at that point in time, because they had this massive amount of data. And they said, hey, we cannot just build bigger and bigger machines. This doesn't work. Let's scale horizontally. Just buy cheap servers, cheap PCs, MediaMarkt PCs, kind of, right? But massive amounts of them. And have a clever software who is distributing these data to these different processors. And then we are able to scale what we call horizontally instead of vertically, right? That was, of course, a big shift in the architecture, and it was very successful. So there was Hadoop. Programming Hadoop was super complex. And then a bit later, Spark was developed, right? And maybe you know who developed Spark as a PhD program in University of Berkeley. These have been the founders of Databricks.
Yeah. But was it only, I mean, I did... A long time ago, I did a track at QCon London, was called the Big Data Architecture or something. It was 2013 or something. And my slogan, of course, I stole it from someone from MIT, was Big Data Architecture. It's for, what is actually big data? It's, I mean, back in the days, yeah. So it was, those data are too big, or too fast or too versatile for normal databases like the classical databases to handle those data. So is that was that kind of correct? I mean, was there also beyond the scaling, like the speed of data coming in, or the types of data, like unstructured data?
The question is, as you rightly asked, what is big data anyway? When data is big and when it's not big, when it is small, right? And actually, there is not a border. You don't say everything bigger than a terabyte is big data and everything below this is not big data. That doesn't make sense. So today, I think there's a consensus. I like this definition. I read it with James Serra. He's from Microsoft, and he wrote a very nice book on O'Reilly, Deciphering Data Architectures. He actually said very simple, big data isn't anything else than just all data. And that's exactly what you said, Sven. It's the kind of data. We not only have this kind of structured data in databases, we have semi-structured database, JSON, XML, CSV. We have unstructured data, text, pictures, video, audio. We have batch data, we have streaming data. So I would say big data means you can handle all kind of data, right? And then definitively with these structured databases and warehouses, you are at your limit. That is not possible.
No. I remember this wonderful quote from my supervisor. It must have been 2004, 2005, when I was working at a wholesale company. And he said, you only felt real stress when you executed a query on the database cluster that brought down the whole logistics department because they had to wait for your query to finish.
Yes.
And that was the time when we bought the Exadata, but only to notice a year afterwards that it was actually idle 95% of the time. That, in my point of view, was a big problem of the data warehouse concept. Isn't it that this idle time, and as you said, with the advent of cloud services, we could somehow have a pay-as-you-go model, but that was kind of clumsy, if I remember correctly. Like the first installation of Hadoop, it wasn't so much pay-as-you-go. It was actually a very big installation that we had there. So when did actually this point in time arrive that we had real on-demand compute for data processing, would you say?
I cannot give you a clear date here.
No, but in terms of architecture, what was this shift?
Very important are these, of course, the cloud vendors. So 2006, AWS started this business. Google came two years later. Azure another 2 days later. But also the development of Spark, I would say, that was 2009. And then the further development of this made the whole thing much easier. And now with companies like Databricks, so you have Spark out of the box. So it's pretty easy to set it up, right? You don't have to turn all these knobs and optimizations. And Spark is a big advantage over Hadoop. Hadoop was really kind of, as you said, right, very tricky to build, to optimize, to write the programs. And the nice thing about Spark, it's a descriptive language. So you don't actually, it's like SQL. You don't have to program how Spark is doing this and how Spark is optimizing. You just describe what Spark has to do with your data, right? Or like SQLs, etc. That is the beauty of this approach.
What I also liked is this repeatability of the pipelines. If you kept your source data, you could like repeat a pipeline and insert new modules into that. That was really nice.
Yeah, maybe we are already a bit too far in the pipeline. Yes. Before we talk about the pipeline, so we said data warehouse, it was just not the right thing. Or it had some issues. Then infrastructure changed. The type of data we wanted to process changed. What was then the next architecture which came up? Was that the data lake?
That was probably the data lake, exactly. And data lake and data warehouse, they exist in parallel. It's not that you switch off your data warehouse and put everything in the data lake. Data lake had some other needs why the data lake was developed, right? And data lake basically is when the hyperscalers came up, like the Amazons, Azures, and Googles. Suddenly, very cheap cloud storage was available and kind of unlimited, right? So you're not storing your stuff on your own servers in the basement. You just could rent as much as you wanted in the cloud environment. And of course, then it was already clear, we talked about big data, that big data is important for the business. And everybody started to, first of all, collect the data, right? Because maybe even you are not using it, but you thought, hey, it's important, my machinery data, sales data, sensory data, website usage data, whatever. No, just let's not delete it. Storage is cheap, so let's store them, right? And later, probably we might need this data. So, and that was the birth of the data lake, because it's just, you take this cheap storage, and in the easiest way, you just have a structure of dictionaries in some way, how you order your data, and you just dump your data on this data lake in whatever format, is it CSV or Parquet files, whatever. And that was I would say, the first data lakes, right? Of course, very soon you recognize all the problems this simple architecture and this simple principle is causing, right?
Can we contrast this with the data warehouse? I mean, we had this example of this Oracle database. Was the idea of a data warehouse still that you have a unified technological like deployment of a certain database where you copy everything in? Or was it already that you kind of federate and have multiple storage backends that you can kind of have on top of multiple technological solutions? And for the data lake, I think there is the file system and files, but I think we also have integrations with databases and query front ends for this, right?
Yeah, that was the next step. Then you go kind of in a lake house, I would say. But to your first question, the classical data warehouses had a big problem with unstructured data. Obviously, they were meant and built for structured data, table-based data. Therefore, they are great. But now suddenly people have more XML stuff or even videos, text files, right? Unstructured texts, pictures, this kind of stuff. And this is really hard to store this. It doesn't really make sense in a classical data warehouse. You cannot use SQL, you cannot select them, you cannot search for pictures or whatever. This doesn't work, right? And that was the reason why they put this stuff on data lakes, because that was easy. It's a storage system, right? And one important difference, what we say between data warehouses and data lakes is, in data warehouses, we call this is schema on write. So when you write some data into the warehouse, you first have to transform it in a fixed schema, right? The data schema. So the kind of the structure of the table, the fields, is it an integer or a float or a text, whatever it is. So you change your data and then you can store it. And when you read it, it's in this schema, right? Always. Data lake is different. It's a schema on read, as we call it. That means you just dump the data there. You don't care about the schema basically when you write it. But when you read it back, then you probably have to transform it into a schema what you need. And this depends on the application. Is it an SQL, an analytics application? Then you have to transform it in a table format. Is it a machine learning application, right? Then it's probably, I don't know, some Python stuff or whatever. It's a different file format. So that is a big difference between the two approaches.
So you said they both exist in parallel, right?
Yeah.
So
they still exist, right? I mean, it's not the whole world switched something off and switched on something new, of course, right?
Yeah, but I was just wondering, because there is also the data lake house.
Yes.
And I was just wondering if the data lake house is kind of the solution to having a data lake and a data warehouse in parallel.
Yeah, that's the idea. And actually, Databricks has invented this lake house concept. I think it was in 2020. And it was, kind of a revolutionary idea at that point in time. Basically, what they said is, actually, we don't need a special data warehouse with a special hardware and all what we described, right, to achieve this performance. We have cloud storage, and that is basically a data lake, right, where the data is in special certain formats, but open formats. That's also important. It's not proprietary formats. On the other side, we have the compute, and also compute is in the cloud, right? And compute is independent from storage, and it's also independently scalable. And with techniques like Hadoop or Spark later, it was able to scale also the compute and get as much compute as you need for your analytics loads. And this combination of having the data lake with your storage, and then having a high-performance compute engine also running in the cloud on top of this, doing, for example, SQL, stuff, that was the birth of the data lakehouse. So, and lakehouse is an artificial word, is a combination of data lake and data warehouse, obviously.
Okay. And
maybe to add this, one really important point was that it was possible with different tools to kind of implement this, what we call the ACID properties on the data. If a data lake is just a file storage system, then of course you have the problems that your read or write fails, right? You cannot recover, you cannot roll back, and this stuff. For small data, it's not the problem. You see, okay, my copy is not successful, so I copy again. But imagine you have tens of thousands, hundreds of thousands of files, right? All the time there might be an error. There can be a network error, hardware error, whatever. And then very soon you have an inconsistent state in your database. You don't know exactly, was everything copied correctly and changed and transferred correctly, or are there some errors here? And this leads to follow-up errors, obviously. And that is the big advantage of the data warehouses, like this commit and this rollback, so that either the whole transaction is successful and you are again in a consistent state, or if an error occurs, you have the possibility to roll back to the previous consistent state. So that would mean you always are in a consistent data state, right? Whatever you do. And in a simple data lake, this is not the case. But with tools like Spark and a layer in between the data and the compute, you could, with software, also achieve this, right? And promise this, guarantee this. That's what we call ACID properties. ACID stands for atomicity, consistency, isolation, and durability. That was a very important step.
Yeah. But in that CaSE consistency would refer to integrity, right? That you can rely on the integrity of your data. I'm currently wondering, Christoph, you said data lake is actually schema on read. And if we combine now data lake and data warehouse, where data warehouse basically means you know which schema you have and you want to query, how does that go together? Conceptually, I mean.
In the data lake, you go back to the old data warehouse, and you have actually a schema on write because you need this. You have in your data lake some very known kind of file formats. Paquet is the standard here, absolutely. And of course, at least for your tabular, the structured data, you have schemas, and you make sure that the data you save in your Paquet files is in that structure. That is important, that the warehouse part of your lake house is working. But you are not forced to this. You can also still dump pictures and text files whatsoever also in your data lake. You cannot query this with SQL, right? But you can use it with machine learning approaches, right? So you have more flexibility in a lakehouse, actually. Another big advantage of the lakehouse is, before this, you had different things. You had the data lake for your unstructured data, and you have the warehouse for your structured data. And you should not forget, you always need some data governance. You need rules. You need who has access to data, what is data quality, all these checks. So this is what we call data governance. That's very, very important. Otherwise, you end up in a data mess, or how we call it, a data swamp, right? From data lake becomes very soon a data swamp, and then you don't find any data anymore. You need data catalog and maybe lineage and all this kind of stuff. If you have a data lake and a data warehouse or several data warehouses, you have to set up these data governments in all these places, probably with different tools. And this is difficult because you have different tools. You have to set it up twice. You end up with inconsistencies. In a lake house, the nice part is you have one governance layer for your lake, and that's the central place to set up your governance.
So it means you wrap your head around data quality of the data that is incoming, even though it doesn't have a schema yet. Or you don't know in which schema it will be queried. Let's put it this way.
Right, but data governance is much more than schema, obviously.
Yeah, of course.
Right. Yeah. So it's much bigger than just the schema. It's, for example, who has access to data? What is with personal data? What is with data lineage? This kind of stuff. Quality rules.
But when it comes to data quality, I would say it depends on the use cases that you have when you query the data, what quality you need.
Yes.
Right? So, for example, taking the actuality of data, where you say, I must make sure that the data is not older than 10 seconds.
Yeah. Or no zeros somewhere, or if it's a text field, you should not have numbers. This kind of stuff. 100%.
And how would you go about this if you say, okay, there is a new use case that we have on the data lake, where we say we want to provide that use case or let's call it data application, but that means that we need to adjust our data governance. How would you approach that?
Yeah, good question. Usually the data is transferred into your lake we haven't talked about this yet, with ETL processes, extract, transform, load. And that's also what we call data pipelines, right? These are automatic tools or scripts or software, whatever, who is moving consistently data from one place to the other. And you would build these quality gates or quality rules, however you call this, into these pipelines as checks, for example. And then you have a governance tool, for example, a Databricks. This is the Unity catalog, where you can manage this kind of rules and this kind of pipelines in a central place.
Maybe one basic question. We talked about data quality, data catalog, data lineage, data access. For those of us who do not really know exactly what this means, can we briefly give a little definition what that is? So what is data quality? What are typical properties of data quality? We had already actuality. What else? I mean, you don't have to list all the ones, but just that all listeners get a little feeling for it.
Absolutely. So data quality, you can write books about this.
Exactly.
Basically, it is, well, data has a certain quality. You expect values, and that is also important. Data is a very technical term. Data at the end is ones and zeros, bits and bytes. But what is important is data is also information. And that is important for the business, for example. What does it mean, actually? And therefore, it has to be in a certain quality. So you define a schema, as we said. A schema is you define how the different fields of a set of data is defined. Yeah, for example, you have a telephone number, and there shouldn't be numbers in this. There should be only numbers. There shouldn't be letters in this. So only numbers and maybe a plus for the country code, whatever. Or you have names with or without umlauts. I don't know, capital letters, smaller letters. This is all things you define. And if you obey to these rules and the data is following these rules, then you have a high data quality. And it makes it easier to interpret the data. If it's not following the rules, you have inconsistencies. You can interpret the data in a different way. You don't know what it means. Yeah, if you want a telephone number and there are letters in there, you say, well, "What should I do with this?"
Yeah.
So if I may rephrase that, data quality depends on what you want to do with your data. So you cannot, in general, say, "I have great data quality," if you don't know what your data will be used for.
Absolutely, very, very important point. Later we will see in when we discuss about data mesh, for example, data quality has to be defined by the business department. The only one who knows what is a high quality of data, if they can use the data, right? And you cannot see it in bits and bytes. You have to look at the semantics basically of the data.
Yeah. Before we dive into the data mesh, I have another question on the quality, if I may, Sven.
Okay. We just go ahead with quality. We still have the catalog and the lineage, but go ahead.
I wanted to know, Christoph, you said with your experience, did you meet a situation where you had different business stakeholders phrasing different requirements that were opposing?
Yeah,
in terms of data quality?
And actually that happens all the time. And later, not yet, but later when we talk about data mesh, you will see that is an approach to deal with this. But of course, in an organization, look at the business. They have the data, they use the data, but there are different departments, and different departments have a different view on data. For example, look at customer data. I mean, you know this from your company, right? If they're the salespeople, they have a different need than the service people, right? Or the after-sales people, or maybe the product people who want to develop new products. They also need the customer data, but different aspects of this data. And maybe they're telling the sales data, hey, I want to have what the customer doesn't like about the product because we want to develop a new and better product. And the salespeople say, I don't care if my customer is not like on my product, so I'm not collecting this. And you always have this kind of fight: who is the owner of the data, who defines the data, who defines the quality of the data. That happens all the time.
I think a typical workflow is also that you just have certain data sets available and people start using it and you don't really know who is using it. And every time you read the data, the program you write has actually expectations on the data. And a data quality problem, it's kind of the expectations of that the program has on the data are not actually matching the reality. And I think a very interesting field here is, how do you facilitate this alignment between the producer and the consumer, and how do you kind of get an overview of all the consumers and the kind of, I've already called it contracts, because I think this is the direction where this is going. But yeah, Christoph, does it reflect your kind of understanding of the space, and what approaches do you kind of see to kind of manage this tension?
Yeah, this is another very interesting development going on in this field. And this has nothing to do with technology and architecture. This has to do with organization and actually the business of the data. As you said, you have producers of data and you have consumers of data. And in the maybe still today, on the old days, you had these data analytics teams, very technical, part of IT. They were dealing with data in a very technical sense. Database administrators. They were looking, table spaces are working well, database is performant, but they had no clue, no idea what actually are these data they have in their database, right? No idea. What does it mean for the organization? Maybe production has a standstill. They just see their bits and bytes. And so that has to change. That's also caused bottlenecks because the business was coming and say, I need this report, I need this LM model. Then the technical people say, I don't really understand, or I have to learn this. How do we do this? And there is a movement to move more and more of these responsibilities into the business. And one of the very exciting things is what we call, they define data products, or data is a product. Like you have internal products, IT is a product, maybe your bookkeeping or controlling is a product, and data is another product. It has a meaning, it has a business context. But a product needs a product owner who is responsible for this product, and he should sell the product to other things, to other consumers, as you call them, right? So the whole thing is moving from a technical aspect more and more into the direction of organizational changes and organizational responsibilities.
Yeah, I don't think it will stay there. I think having it in business and in management is kind of just a sign that it's important. Like people are sufficiently caring about this, that you have like business stakeholder caring about it. Yeah. I think they will try to push it down to tech again, and it may not be the data specialists or data analysts. I think it will be software engineers that are like more tightly integrating these things. And
that is an interesting viewpoint. And of course, we probably could discuss the rest of the evening about this. That's exciting. Yeah.
But maybe let's get back to Sven's catalog and continue that.
Exactly. Yeah. Oh, I want to mention on that, famous last announcements. But we all in the future we have an episode with Simon Harrer on data products, data contracts. So that we have the chance to basically talk 1 hour about data products. Yeah, okay. So we had data quality. What is a data catalog?
Good question. Data has to be what we call observable. So this is the observability of data. That's very important. If you just have a few data on your laptop, that's not a problem. You know your data and use it on your laptop. But imagine an organization, a huge organization with tons of data. If you want to use the data, you first have to discover it. You have to know what kind of data is available. Yeah? We talked about customer data, and imagine there's not just one file with the customer data. There are tons of data sources about customers with all the different aspects. So what is the right one to choose? You want, for example, to build a new report. I don't know how customers are using a special product of your company in a special region, dependent on the weather. Just an example, right? So what kind of data are you using? What is the correct data? And so that is what we call data has to be discoverable. People have to find out and say, okay, this is exactly the data I want. This is the description. This is the description of the schema, of course, of the fields I can use to build more complex reports. And this is what a data catalog is doing. So where all the data sources or data products, however you call it, are described, and people can discover the data there.
Okay. I know a product for this. I just remember it's called...
I think Colibra is the main player here, right?
Sorry?
Is Colibra the main player here?
For example, I wouldn't say the main player, but definitely an important player on the market. Okay. Absolutely.
Yeah. All right. Then we also had data lineage. What is data lineage?
Data lineage, also important, is where is data coming from? What's the history of the data? Yeah. So you look into a report or into a data product, and you want to know, hey, actually, where's this data coming from? So who has entered that data? How has this data entered the organization? Is it coming, from a sensor, from the internet, from a machinery, whatever? And maybe who changed the data on the life cycle of this data? And this is, for example, important. We all here in Germany and Europe, we have GDPR, right? This general data protection, regulation, exactly. And users or consumers have the right that their data get deleted. And so you cannot just delete it in one database. You have to look, where is it coming from? Because, there's a lot of replications, there are pipelines. If you just delete at one place, it pops up again. So this is not helpful. And so you have to delete it at the source, for example, in all systems. Or if you do, you do debugging, you have errors, you find out data quality is bad. Why is this? Why are the fields wrong? Or the schema is wrong? For this kind, data lineage is very important. And in particular for all this regulatory stuff. If you think about banking, insurance, they have by law, they need to show where is data coming from, where it is transformed and changed. If this is financial data, for example, that's super important. It cannot just pop up somewhere and disappear again. So you have to really show how this data is traveling through your architecture and your organization.
What I like about the data lineage aspect is that it helps you validate your assumptions. So assumptions in terms of what can I actually do with a certain information or data point. Because you can always verify, okay, it's coming from that system. Okay, that system will not be able to update the data every 30 minutes.
Exactly. Yeah, we talked about data products, and if you think about using a data product for some reporting or some business need, then the question is this the right data, as you said, Alex? And the question is, of course, where is this data coming from, right? And who at the end is the owner, maybe, or is responsible for that?
Who has touched it in between?
Yeah, exactly. Who has touched this?
And therefore, it helps you to sort of say handle stakeholder expectations.
Exactly. Yeah, and you can explain. And one thing with data is very, very important is the trust into data, right? If we see this in organizations when people saying, I know there's this warehouse or this data lake and there's tons of data, but I really don't trust it. I got a report, but it was a lot of errors and I don't trust it. Then they are not using it. And you will never get it into production and in usage. So trust in data is very, very important. And if you can show the lineage where things are coming from and where maybe something went wrong and you correct this, it's very important to trust into data.
What I also noticed is sometimes, I'm not saying this is the usual case, but sometimes stakeholders have very high expectations in terms of quality. Like this needs to be up to the millisecond correct and precise. And with the data lineage in place, you can actually show them what costs it would create if you had to have this consistency, so that actuality of data. And that gets you into, I would say, more constructive discussions, because in the end, the stakeholders would be the ones that had to invest this amount of money.
Yeah,
in order to
and this
get
is another
requirements.
very important aspect, is the whole financial aspect of your data management. Imagine if you have everything in the cloud, it's pretty expensive. It's really a significant amount of money you're paying to the hyperscalers, obviously. And it's of course the management want to know, okay, how much are we paying for what, right? You have tons of use cases, applications, departments, and they're all working in the same data architecture on the same cloud provider. But who is really generating which kind of cost, right? That's important information as well.
Isn't it? I forgot the name of the product, but their marketing slogan was, put all your data into our data lake. It's very cheap, and it was extremely expensive to get the data out there.
Maybe it might be the case. But for this also, lineage is important, right? To see where data is traveling, and then also having the associated cost to this, as Alex said.
I mean, this is, if I had a magic wand, I can just have one thing, then having perfect data lineage, I think, would be ranking way up there. And why? I mean, I really like to think of the parallels between microservice architectures and data architectures a lot, and how can we learn this? And in the microservice space, for me, distributed tracing really stands out as a core enabler of observability and debugging that allows you to reason kind of cross microservice, right? you cannot really understand reliability of a single microservice. You have to piece it together and have this multi-system interactions that you need to understand.
Understand the relationships.
Yeah. And here you have really HTTP requests that are nested. And you have, every time you're processing something, you really have a chain of sockets and memory that is allocated in different microservices that are like the context of a transaction, give you the context of a transaction. Yeah. And with distributed tracing, get information about the state that you can like understand causality. Why am I here? Like, who is the user who expects something from me, and so on. And you, even without the distributed tracing, it's still in the moment you're doing the processing, you have all this kind of connections and all this memory allocated. You have this information in the system somewhere. And with data, I always feel like, okay, we have thrown all of this away. Like once we produce that row in the CSV file, we erase everything. It's gone. It's no longer there. And all we are left is with the result. It was 35 euros this thing costs. And we don't know which kind of version of the code produced this and all that. So it's very decoupled. It's kind of the attractive bit about it. So you're not like limited in kind of having all the system around you while you do the processing. But it's also, well, you threw everything away. Like you just retained the output. And I have a fundamental kind of a hunch that we have to retain a lot more information about the processing in the way we publish and handle data. And that's, I think, fundamentally something that should be enabled through data lineage or systems that are handling data lineage. And an additional complication here, just to say one more bit, is the platform aspect. I think probably if you're all in Databricks, you can have kind of better tools. If you're all in Airflow, you can solve parts of this. But what if this arrives on an FTP server or something, and then it goes to Kafka, and then it hits Databricks, and then you have a custom reporting application after that. So how it does would that look in the end? How can we approach the problem?
This is a very good. That's a $1 million question. I would say that's a project. Maybe before we dive into this, Heinrich, your first questions. I don't think that you throw everything away. Maybe that was in former times, or this is the case on your laptop when you move files around.
Okay.
But in Databricks, we have this Delta layer, right? And you have time travel, for example. You can go back in time. You have all this versioning. So all this information is stored, actually. All this lineage, as we said. You have this information available. The problem is how to use it and what do you do with that. But the data is there. It's not thrown away.
Okay, so one more reason to really check out Databricks in more detail to understand all this power. Yeah, but I fundamentally think we have to retain it and build better tools to leverage it. I mean, I'm a reliability engineer, so a lot of the use cases I care about are, okay, we have a data quality problem or data availability problem in production. Like, what the hell is going on? Yeah.
Yeah, and of course, putting these two together, of course, augments the complexity of the solution 100%. On the other side, that's what customers usually today like. They like this best of breed, and it makes a lot of sense. Yeah, you're not going to buy everything from one vendor. You choose the things, and you use a lot of open source tools, but you have to stick things together, right? And of course, you have this kind of complexity. But also, the real life and the business you are implementing is also complex, right? So don't expect that your data architecture actually is super simple if your life you are managing with this is very complex.
Yeah.
If there is inherent complexity, you cannot remove it.
Exactly. Don't make it easier than it can be, right? But also don't make it more complex. 100%.
I would like to go back to the Delta Lake topic for a second. Just if I understood the Unity catalog concept correctly, Christoph, is it actually correct that in order for Databricks to be able to support you, when you import a certain record of data, you have to describe the relationship to other data points, even be it if they are outside of Databricks? Otherwise, if the Unity catalog doesn't know about a relationship of one record to another data point, then it obviously cannot help you. Is that correct, the understanding?
Yeah,
or?
I mean, we are not forcing any customer to use Unity Catalog. So Databricks also works, or Spark and Delta without the Unity Catalog. But Unity Catalog, of course, as we said, has huge advantages. That is the Databricks product for our data governance, right? For example, we have the advantage, I would say it's an advantage, not only include the tables which are on the Databricks platform, but you also can include and manage tables outside of the Databricks platform, if they are in Parquet or a Delta file format. But for this, of course, you have to register these tables in the Unity Catalog. Otherwise, this is not possible.
What I wanted to stress is, from my understanding, Unity Catalog is not only an enterprise data catalog, like, I don't know, Data Hub, for example, this open source version, but it actually comes with a lot of additional features that would be helpful to improve data quality, or actually make data quality visible in the first place.
Yeah, absolutely. We talked about Lineage. We talked about quality rules, registering the tables, and observability of tables and of data. This all is managed in the Unity Catalog. That's correct.
Yeah, and to be honest, Heinrich, I didn't get through all the power of Unity Catalog either. So it's really something to look at every now and then in order to understand even more. That's anyway the topic with data, right? If you gain new perspectives, you should look at your data with this new perspective in order to see whether you need to change something on the data governance.
And in every data architecture, the data governance tool is really a central tool. It's really a centerpiece for basically everything. And for Databricks, it's the Unity Catalog. And therefore, we have all this functionality in this tool.
Just one tangent here. What is the granularity where a data catalog is cataloging the data? And the discussion that we had internally was okay, we have maybe a data set around customer, but it's not one data set. It's actually 15 data sets and 3 APIs and something more. And then there is this concept of a data product you already alluded to. And so there was a lot of discussion, what is the right concept that we should track and how this thing is exposed. If you're just kind of listing a schema dump, every kind of data set or table we have somewhere, then I think there's a risk of kind of being too fine granular. And if you're zooming out, then there's, I think, always an ontology question where it's okay, where to draw the boundary. Is there some guidance you can give for this kind of problem, or how is this generally approached?
It's hard, I think, to give general guidance on this. This really depends on the use cases, on the customer situation, on the architecture, obviously, right? I mean, the granularity goes down to tables, I would say, even to columns and lines in the table. You can have column-based authorizations. You can define this, right? Yeah. So even down the level, down to lines and columns, and then on the other side, you can combine tables to databases, and so you can really play in the right level of granularity you need for your use cases.
So the tool is generally capable, and how to approach it, really look at the use case and see what kind of your users think to work with. Yeah.
All right. We still have one architectural style left. Right. I want to, before we dive into more topics, I just want to talk briefly about that one. It's the, I was about to say the new kid on the block, but it's already 5, 6, 7 years old. 7 years, I believe. And that is a data mesh.
Yes, it's 6 years old. Yeah.
Yeah. So what is the data mesh?
Yeah, very good question. What is the data mesh? It was developed by Zamak Dagani at her time at ThoughtWorks. I was working with her actually. And I think, Heinrich, you said this, and this is exactly what is behind it. You talked about microservice architecture for data. That is exactly the idea behind the data mesh. actually what ThoughtWorks has developed, like microservice architecture, but also very important, this domain-driven design. Maybe you remember that's another architectural pattern for software development in big organizations. This just was combined and said, can't we use this for a data architecture, right? And so instead of microservices as a software service, Zhamak defined data products as one central piece of data as a product, and you can like Lego blocks, you can connect these different data products, so they have input and output standardized, and you can connect them, and then have can create very complex reporting and analysis tools, right? So that is the one idea. The other idea is that these data products actually belong to into an organization, into a domain, into a business domain. So this is this connecting the technical architecture as a product with the business domain, with the business surrounding. And this is also what this domain-driven design is doing. If you know, right? You define the different design or the different domains, business domains, and then you organize your whole software architecture along these design rules and not independently through an organization. And this really reduces the complexity. That's the same what you do with data mesh. You define your data products along these business domains, and then you reduce complexity, and you define clear ownership. Who is responsible? Who is the owner of a data product? It is in this business domain, right? But from this, you see the data mesh is not a technical architecture like a lake house or a data lake or warehouse. It's much more an organizational pattern. And that is very, very important to understand. So it's not a technical implementation project, implementing a data mesh. It's much more an organizational or transformational project in the organization.
May I just mirror what I understood and you correct my point of view?
Absolutely.
So when I think about this kind of microservice architecture, what I heard reminds me of like domain gateways and like ways to kind of put interfaces in between so I can segregate domains better. So
Yes.
If I naively translate this to have a data architecture, I would just say instead of exposing tables, I kind of create specialized views that I give to certain stakeholders so that data is kind of consumed through these views.
Yeah.
Is that kind of the basic?
Exactly.
Principles.
That's exactly the same. In data mesh, this is called, so every data product is what Zhamak called the polyglot data ports. That's her name. Polyglot means it is independent of technical standards. It can be batch, it can be streaming, it can be graph, it can be SQL, right? That's independent.
Yeah.
But it's kind of a data port, and there are input ports and there are output ports. So you can collect data from somewhere. Then you do data transformation, whatever you do with the data. Could be SQL reporting, right? Filtering, could be a machine learning tool, whatever, classification. And then you have these output ports where you provide, again, this data. And important, these are kind of polyglot. And of course, you need a technology underneath who is managing all of this, of course.
Can you kind of republish on the same port, so to say, a new kind of transformed version? Exactly. Or are they always kind of read-only once they are written? But
well, the output port is read-only, and the input port is you write into this. Yeah. So you have both directions, but you can stick these ports basically freely together, and you can create new data products, reading from some data products and then creating some new knowledge or data, and then providing this data at the output port for other consumers.
So I'm thinking now of a multi-step pipeline. This goes into a related problem, which is multi-domain ownership or cross-domain data sets. So I may have like a producer, like say an e-commerce platform. So you have a partner who provides a product for you, then you have certain augmentation steps, and then you finally feed it to a catalog. So you have 3 different domains that are owning it, kind of partner integrations, then and so on. So in the one model I have in mind, you would have kind of certain channels or fields that are maybe owned by the partner integrations and that are kind of fed through. So they may be dropped in subsequent views, but they may be just passed through. Then there are fields which are kind of added to a thing. This is by a certain domain that's relatively clear. The question would be, is it allowed, it's more a technical detail maybe, but is it allowed to kind of mutate certain channels which are already predefined? And then how would you kind of have the ownership of those? Because those things, I think, then it gets really hairy when it's like, okay, this is something that was produced by partners, but now we kind of see like two-stage derivatives being published under the same name.
Yeah, so what you do, you define or build your new data product. So what you're describing, you have a need, you want to do a data transformation. So basically you define your own or a data product. You are the owner of this product. You are responsible for the quality. You can read from other products. You cannot change this in the other products. You can just read the data from them. That's read only. But when the data is in your product, of course, you can do whatever you want with this data. You can delete, you can merge, you can whatever, right? Drop. That is your responsibility. And then you use the data by your own. And you also offer this new data with an output port to other organizations. Yeah. So you as a data owner, and that's the beauty of this product concept, you are kind of responsible also to offer your product to others in the organization. Maybe they find this super helpful and say, that's great what you're doing, exactly what I need, but I have to modify it again. That's I'm doing in my product. That is the whole idea of data mesh and data products.
But isn't that like a how do you say it? Like a chain reaction? We had this this wonderful case in the microservice architecture when one microservice was calling another microservice, was calling another microservice, was calling another microservice. So how do you resolve or actually guarantee data quality if you are dependent on someone who's dependent on someone? You know what I mean?
And there comes the contract in place. I think we mentioned this already. So the output ports also have a contract where this is the same as in microservice architecture, where you describe the data. And this actually happens in the data catalog, where it is exactly the schema and the quality of the data is described. And the owner of the product is responsible to adhere this quality, right? So you rely on him, absolutely. If you find out something is wrong, then of course you call him and say, look here, this is not along the contract or the data catalog. There's a problem. That's the way this is managed.
So as I know that I cannot predict production, I'm currently wondering whether there is already a resilience patterns for data.
Well, sorry, what do you mean with this, Alex?
I mean, there's this wonderful book by Michael Nygaard who wrote about resilience patterns for in-the-end applications or microservice applications, where you have patterns like the bulkhead or circuit breaker, and that basically says, okay, how can I make myself resilient if my relationship partner doesn't fulfill the contract or the expectations that I have, and that could be that I return a default value.
Yeah, I think it's a very, very good and valid question. I have actually no answer to that question. But you see, the main challenge of a data mesh product and introducing and running a data mesh is not the technology, it's the transformation, is the behavior of people. And sometimes it changes completely the behavior in companies of people. I know maybe you also have examples in old companies. There was, if you have data, if you're a data owner, you have power. And you're not easily distributing and giving this data away to others. You say, hey, this is my data, right? Salespeople say, no, of course you don't get the customer data. No way. It's power. And data mesh turns this exactly in the opposite way. They say, I'm an owner and I have to distribute it. That's a product. I have to offer this product to others in the company, right? And you need incentives and you need whole management and governance around this, that this actually is working.
But spinning this for a second, Sven, what would be your recommendations in terms of adopting this towards data governance? Like if we think of data mesh, for example, which so to say distributes responsibility, but at the same time makes responsibility very explicit in the role of data owners. What effect does that have on data governance, would you say, or what would be your recommendations?
Yeah, in my experience, and when I worked for ThoughtWorks, I worked in projects where we implemented data mesh architectures. And the most difficult part and the part who took the most time was actually this organizational change. So it starts with defining the domains. It's not that easy in an organization to really find the right cut and granularity of data domains, right? That is already the first fight. And you need really senior people in the room to help you with this. It's very important. Next step is, who are these product owners? These should be people from the business. They have no idea about data and IT and SQL and databases, right? They suddenly say, I never did this. So what is my job? What does it mean? And now I have to build data products. How do I do this? And how should I do that, right? It's a complete new job description. And you need kind of IT people, or at least analysts or developer, who are actually developing these data products. So you have a decentralized organization, which usually companies don't have. So you have to also change that. This is the biggest challenges of data mesh projects.
What I'm currently thinking, Heinrich, we might somewhere soon see an extension of data aspects into something like service level objectives.
Oh yeah, this is actually already happening. Like the last project that was the last year, like I was personally doing data SLOs for a lot of the data sets, and we're running in all kinds of like problems that are like along those lines. And maybe just to bring a new kind of impulse here, I would also be curious, Christoph, like on the macro perspective. AI is, I think, driving a lot of this. So if I'm like looking at data as a whole thing, I think for a long time, all these problems existed, but they were like, it's the problem of the business analysts to kind of figure this out for their KPI runs. And you had a certain amounts of friction, manual labor, and just incorrectness that you kind of tolerated. And I mean, not everything is perfect. So you just write your big ass SQL query and just get along. And now I think it's shifting. It's really like, hey, we need to integrate tons of data into RAGs or into chatbots that are then really business critical. And that's like, it's different animal than kind of catalog data or like customer data that was already in those kind of mission critical systems. And yeah, what's your kind of take on that kind of global shift? What are you already seeing? And like, what is your extrapolation of that maybe over the next few months?
Yeah, great question. So let's look a little bit into the future. But before this, maybe one step back also, because I find this very interesting. You know, you have these in an organization, you have these kind of flows. You have usually when you produce something, you have a material flow, raw material, you produce something, that's your value creation. Then you have a financial flow, right? You have costs, you have revenue. That also has to be tracked by controlling and in finance. And you have an informational flow, right? Information is flowing through your organization, needs at certain points for decisions, is generated somewhere and is used or consumed at another place. And I would say in the good old days, 20 years ago with SAP ERP system, all these flows have been managed in one ERP system. But in particular, the data side, it's becoming bigger and bigger and larger and larger. And today you cannot just manage all the information flow just in an ERP system. That's the reason why you need these information architecture additionally to an ERP system, right? And now you are mentioning Gen AI and machine learning and AI tools, and that again makes it even bigger and more important, right? Every decision somewhere in the organization needs this kind of data, is data-driven ideally, right? And at some point in time, probably also is automated. That's what I would assume in maybe five years. You know, SAP is investing heavily also with Databricks as a partner into that. And today there is maybe an SAP administrator sitting in front of his screen, getting some data and doing some decision and clicking some buttons. And of course, that probably can be automated by a large language model, right? So, as you said, this getting more and more data, because as we said in the beginning, you have to collect that data, you have to manage that data. It has to be in the right quality. That's very important. Otherwise, your LLMs are not working properly. You have to monitor this. But you also need the right access rights. Not everybody is allowed to see every data. And that is a big challenge with large language models, because you cannot explain them, hey, this guy is HR and he can see this personal data, but this other guy is not HR. So please don't show them the paycheck from Heinrich, for example. So you do this with RAG systems, as you said, you do this with vector stores. These are the kind of classical databases for vectors. And then again, you have all these access rights which you can manage. Then you have the updates. I mean, if you need your product catalog in a RAG system, right? You need this for decisions or for customer recommendations. But your product palette is changing constantly. I mean, in your company, you know this by heart, of course, right? All the time. So how do you update this? You cannot do this by LLM training. This is not working. LLM is not forgetting, right? It ends in a mess. So you also try to use classical database architecture again, which is super interesting for your vectors, right? For your knowledge vectors to manage them.
Yeah, I think right now a lot of this is just driven by batch jobs, which are running on a daily basis or something. And having the data available is pretty critical. I think if you extrapolate it out, probably it's going to be a little bit more fine-grained, maybe hourly or online in the end game. But a lot of this is currently relatively classical, and the integrations are relatively naive as far as I can tell. The RAG, I'm always underwhelmed when I reread about what it exactly is. Just take the query, then do some lookup keyword search on the query in the classical information retrieval, and then just put it in addition to the prompt and say maybe these documents are useful. And I think we will see more creative ways to dynamically integrate. But at least, I mean, my view is very limited on this kind of refinement training, and training new language models kind of is it's not happening so much. I think the majority is really relatively basic integrations. And but yeah, the availability of the data, the quality of that data is certainly business critical. And so you have really, we had some issues and there is production impact and revenue impact if those stuff not there, versus KPIs in a business meeting missing do not have this direct implications.
Yeah, I think what you're saying is right, but don't forget we are moving really fast. Not we, but the whole field.
Yeah.
The whole AI field is moving crazy fast. Remember, I think it's 3 years ago that ChatGPT came up, and everybody was flashed by that. Just 3 years, and now a lot of companies at least thinking about use cases and doing POCs. Not everything goes into production, of course. And one reason is we all know LLMs are not perfect, obviously. They do a lot of mistakes. They screw up, they hallucinate. And at least in applications which are customer facing, you don't want that. That is way too dangerous, right? It could be hacked. It can be very nasty comments, which really is a catastrophe for the public, for your company, of course, right? So I see companies for their employees internally, they are already more advanced and doing stuff, right? With RAGs and with fine tuning and training of LLMs, but customer facing, they're still very, very careful.
I want to briefly go back to the different styles, like data mesh and data lakehouse. One final question from my side on those styles, because for me those are architecture or data architectural styles. Like we have also architectural styles in let's say normal software systems, like microservices, pipes and filter, stuff like that. So now those styles, if I have to make a decision, what kind of style I want to choose, then obviously I need some requirements, and I have to based on my requirements, I have to decide, do I now want to go for microservices or monolith or whatever, right? How is that for data mesh and, for example, data lakehouse. If I'm an organization and I have to think about a data architecture, I have no idea. Yeah. So my personal feeling is everyone who uses microservices, they're like, oh yeah, we of course we use domain-driven design. We have bounded context, and per bounded context, we have a service. And of course, we use data mesh as our data architectural style. And I'm just wondering, is that always correct? What questions do I need to ask in order to make a decision? Is data mesh the right thing? Is data lakehouse the right thing? Is it even possible to have a mix of both?
Yeah, definitely. So in particular, data lakehouse and the data mesh, they are not exclusive, and the other. Data lakehouse is an technical architectural pattern, how you build your architecture. Data mesh is more an organizational pattern. And for example, you can build a data mesh with a lakehouse or with several lakehouses. And a lot of customers are doing this actually. The question, what is the right architecture for you? Of course, there is not just a simple answer to that. But one thing is very clear is nowadays, I would say you have to go to the cloud. That makes a lot of sense. You would not have the stuff on-prem. Maybe you are, I don't know, top secret or whatever, right? But usually you would go into the cloud. Then you can have a particular data warehouse in the cloud, something like Redshift, for example, BigQuery, Google. If you heavily use transactional data and analytics, classical analytics on SQL, Snowflake is another example. But the problem is, of course, if you go more and more in the AI, ML, Gen AI space, that doesn't work with this. So you would need a data lake for your data. And then you should consider really, and I think the whole development is going in this direction, is the lakehouse actually. And it's not only Databricks who is offering this, Microsoft, Fabric, and others. They all go in this direction of a lakehouse because it makes a lot of sense. It is a combination, as we said, of both. You have the data lake, you have the governance, and you have your warehouses performant in the cloud. So I would say from a technical architecture, the lakehouse is probably the way to go nowadays. Data mesh is then the next question from an organizational and data governance type. It's really a much longer way to go, as we said, regarding all the transformation of your organization, of your business. But if you want to go in this kind of microservice organization, the ownership and data products, then data mesh is I would say, the right way to do this. I would say, and it's a bit controversial, it makes sense for larger organizations. If you are kind of a mid-sized small company, I don't know, 1,000-2,000 employees, you have a analytics department, and they're probably fine with the lakehouse and can build the reports and everything needed. But if you are a huge multi-international organization and you have to organize the data between different continents and different architectures, then probably a data mesh makes a lot of sense. Yeah. But of course, data mesh, you cannot just easily implement it. It's always also some custom build. You can, of course, use Snowflake, Databricks, or Microsoft Fabric, but you have to stitch a lot of things together, right? You have to build the data catalog, these interfaces, what we described. So there's still a lot of custom software development necessary.
And when I decide to go for data mesh, I probably can also introduce that incrementally over a few parts of the organization.
Yeah, of course, you would never do this as a big bang. That makes no sense. It doesn't work. You start with an MVP. So usually you start with one domain and you define a handful, maybe 1, 2, 3 products. And you define these products, you build the platform to run these products on that platform, and then you already can combine them and you get the first results, and people see how this works, right? So, and I saw in customers at ThoughtWorks, when we implemented data mesh, in the beginning, a lot of skepticism, a lot of theoretical discussion, but when you had the first products, people were coming and saying, oh, I also have a product, and I also have a product, and can we also implement that product? Suddenly you have a huge demand in the organization, and you have to say, stop. We cannot build thousands of products here, so we have to organize this.
Yeah, so, I mean, I wanted to, to go through all the different styles. So I'm now happy. But Alex and Heinrich, you had some more detailed.
We have a huge list
further
of questions.
Yeah, I have two actually tangents here. And maybe you can choose which one you want to take. The first one is streaming in comparison with those things. So kind of like, what's the relationship, and is the lake actually something that flows or something that stands? And the other thing is around DuckDB and local compute. And I'm just like started using DuckDB recently, and it kind of is it's kind of this shim library that allows you to query all kinds of data sets, like maybe a data warehouse would, because you have your Parquet files lying around in file systems, and it's kind of this scale down idea, which I like a lot. So having like technology you can use on a single node that adds value, that is like has a trajectory to scale out and kind of sit behind the big cloud compute. Like I would just like to get your take on that, how you view this kind of coming into the picture.
Let's start with the streaming, maybe. Streaming getting more and more important. That's what we see with our customers, right? More and more streaming use cases coming. Streaming doesn't mean 100% real time, 0 milliseconds. Streaming can be 100, 200 milliseconds, maybe a few seconds. Right? At Databricks or in Spark, streaming is realized with kind of mini batches. You have kind of mini blocks of data, which is moving between tables like in batch, these kind of mini batches. But because they are fast and they are small, it's really a kind of streaming. Basically, you can handle it the same way as batch, right? It's not a big difference. Of course, there are differences how you deal with the data, but basically, it's the same thing. That also goes to what we said in the data mesh, these polyglot ports, right? It doesn't matter if this is batch or streaming. On a higher abstraction level, it's basically the same. So streaming is a part of this, and streaming is getting more and more important. So it's flowing.
I have one tangent that is a story I want to tell about the mini batches, because I was doing stream processing in my former life, and I was always annoyed by the micro batch topic because it was like, no, I want to process the messages like one at a time. Why are you forcing me to take this batch? Then I built the stream processor, which is based on message processing, and it was slow as fuck. Because it was just like every message that you get, millions, you had to traverse your call stack up and down and up and down and up and down. I couldn't get this to run faster. So I was like, okay, at least for the offline use cases, I need to build a completely different query engine. So everything is kind of vectorized and I'm taking big stuff. And then I was like, how nice would it be if this is kind of unified and I could operate on micro batches? I was
exactly.
like, this is why they did it this way. So it's like, okay, you have been there, and you know that this kind of, I don't know, RabbitMQ style of individual message processing doesn't scale. So if you want to have something that's kind of able to either do a high volume or to do batch and online at the same time, you will end up at micro batches in some form. And this is actually what you probably want in the stream processing use cases. And probably you can tune it in a way that the micro batch is a single message. So if you really, really want to be like super up to date, then you can just do that, right?
You have to use Kafka, right? There you can do this. Some special software, you have single events which are flowing around. If you really need this in your use case, then you would use these kind of tools.
Yeah. And what about integrations between stream and this batch systems or this lakehouse or warehouse things? So is this really common that you have basically your pipe ending in the warehouse, or probably that is kind of how it works, right?
So in Databricks, it's not a big difference. It all ends in Delta tables, right? That's the data format. And if it is coming from streaming or from batch, it doesn't matter. At the end, it's a table where the data is.
Yeah. Okay, that makes sense. Alex, I know you look like you have questions.
Yeah. A lot. I was just thinking as Heinrich shared the story. It's like you said, okay, the industry is moving so fast. We're actually learning new things every day, and I'm trying to look at takeaways that, for example, our listeners can apply on their daily jobs. And I was wondering, Christoph, how do you personally decide which learnings you take into your decisions, and where you say, well, that is actually a learning that is outdated in the meantime?
I don't have a easy answer and an easy rule for this to say, okay, this is I'm going to read. This is I don't look at. At the end, it's what interests me, right? You need to be curious and keep curious in your career and your job. I mean, that is the way in our career, in our jobs, we have to continuously learning and be curious and learn new things. And this is also the exciting stuff about our job, right? What I really, really enjoy. And so I take some time away. I try to do this every day to really check the internet and X and the different platforms and see what is new, what is coming, and try to read maybe one article a day. It's not always possible as a manager, but really to keep up. Also sometimes trying to play around with little Python scripts, right? Try things out. And in particular in Gen AI, with very simple few lines of code, you can do amazing things, right? And this is also something I enjoy, I have to say.
Couldn't agree more. And it's actually like trying things out actually makes me understand whether my assumptions in terms of is that a decision that is reversible or irreversible, which I usually take as the main criteria in terms of what I have to put as governance in place. I learned that on the one hand, there can be new technology that makes things reversible, so that I can actually take a decision more lightweight, or actually leave it to a team. If it's reversible, it's not a big problem. Yeah. At the same time, reversibility is not always a technical thing, right? So, for example, when it comes to data governance, or actually governance in general, I understood that sometimes it's hard for people to reverse a decision. To say, well, actually, this is not put into granite, and we can do it differently. And like I'm currently wondering, as you said, the industry is moving so fast. How do you approach your colleagues with such things of reversibility and technical evolution? So in terms of engineering culture, for example, at Databricks, or in general when you're talking to colleagues in the industry.
Yeah, that goes into company culture and how to preserve this. I think we are very happy at Databricks. We have a great culture, like in other tech industries. I think in general, in the tech industry, I worked in mid-size companies in Germany, which was completely different, and I am very happy to be out of that, to say. but I worked with SAP, Capgemini, ThoughtWorks, now Databricks. It's all the same. These are really smart people. I have to say, they are open-minded just already by their job, right? And this kind of reversibility, Alex, I don't see this as a big problem. They admit errors. They would not say, I said this architecture is the right way, I stick to this to the end. Nobody would do that. At least it's my experience. They would say, okay, that was my assumption, but I was wrong. So sorry for this.
That's
and
good.
You know, we have a very nice saying at Databricks and also at ThoughtWorks, same thing. Don't ask for allowance, ask for forgiveness. And I think that's a very, very nice thing. Do something, right? Because we move fast in the industry.
Exactly.
You cannot wait until some manager gives you the green light, right? For days. Do it. If it's wrong, it was wrong. Then correct it. Fail, but fail fast, right?
Exactly. And innovation is not possible without failure. That's 100%, basically
100%.
the thing. So when it comes to your personal experience, I was actually looking to tease you a little bit in terms of recommendations for software engineers out there. Like, what would be, let's assume there would be software engineers building on top of Databricks or building LLM-based solutions. What would you say are emerging technologies, trends where you would recommend them to look into?
Yeah, in the LLM space, definitively at the moment, agent-based systems. I mean, you maybe some, what is it, from China coming great system. I think it was Magnus was the name, DeepSeek. Yeah, exactly. The next thing is building components of LLMs. One is doing the reasoning, one is doing the planning, and they are specialized. Glue them together. That is a very, very exciting thing. Another very important thing in LLM development is actually the fine-tuning. Because you have to adapt the LLMs to a domain or to a company. We talked about this. Can be done by RAG, but there is certain limitations with RAG. We also talked about this. So people also using fine-tuning. And in particular, reinforcement learning, I think is super, super promising. So DeepSeek used a lot of reinforcement learning. Also, when you train an LLM on boundaries or guidelines, you do this with reinforcement learning. Maybe the last word, what you said, Alex, you have to try things out, right? This is kind of this grounding of the knowledge. We as humans, we know it's super important. You cannot just learn out of books and never try it. It will never work. You cannot learn driving a car just by books. You have to drive it, actually. And same for software. LLMs are kind of learning on the books, learning from the data they get, right? But there are new ways, for example, giving them a sandbox where they can actually try coding if they are copilot for coding. And this, I have the hope, will let them go through this kind of ceiling they have today by the knowledge and maybe even reach superhuman performance. That's the hope, right? So that I think is super, super exciting.
I really like your excitement and engagement on that. Taking this a step further, assume you have a big company, for example, in Germany, and people who are tasked with data governance. What would be your recommendation to the data governance team to allow such experimentation and innovation?
Data governance at the end is everything. If you don't have governance, you have anarchy, and you cannot, as a company, you cannot work with your data at the end. I would say it's like traffic. I mean, if you have a bigger city, you need traffic rules. You need traffic lights. You need signs. Otherwise, you have a mess. You have a chaos, and you cannot go from A to B. Same with data in an organization. Without rules and governance, it will end in a mess. You don't find anything. You don't know what is allowed. You're doing things which are not allowed, etc. So data governance today is one of the most important things in organizations. So I would tell this to the team and say, you are on a very, very central point for the success of our organization.
Thanks a lot, Christoph.
Yeah, talking about governance being, without governance, there is anarchy. So the same applies also to software architecture. Yeah, yes. I mean, if everyone can do whatever they want, sure. I mean, it's a catastrophe. Yeah. But now, I mean, it's maybe not a catastrophe, but it's really fast, bad. Right? But I mean, in software architecture, I'm just citing here Martin Fowler. Martin Fowler said once, governance, it's a scary word, and you can see it in two different ways. One way would be, it's hard rules, it's you have to do it, it's if you don't apply to the rules, you get in trouble. The other one is guidance. We help you making decision. It's like decision scaling. We have guardrails for you, but you have to use those guardrails. Is it in data the same that you say the governance is guardrails? Maybe you can break them once in a while, but usually you should stick to them in 98% of the cases.
Depends on the reliability you want to have, right?
For example, there are very strict rules how you use personal information. And you cannot just, there are the 2% where I just looked into the salary, paycheck, or I got this information. No, you can't do this. Maybe it depends a bit. Maybe there are areas where you say, 80% is fine for me, right? And in particular, if you go with AI is capable of understanding data, even if the data quality is not perfect. So then you could say 80% of the address data is fine. That's good enough, perfect, right? But in other things, look at governance, banking, public service, you cannot allow this. So I think it really depends on the use cases.
Yeah. I mean, in software architecture, it's similar. I mean, if you have some sort of authentication, I mean, or also data protection rules, there is no. I mean, you could say it's guidance, but it's actually set in stone. Rules. Yeah, it's just a nicer word for rules.
Right. Maybe another nice example to this, and this brings us back to the very beginning of our talk, and it's a completely different domain. It's again the music. And I told you that I'm playing jazz, and jazz actually is very interesting because it gives people the utmost freedom. You know, jazz is improvisation. But it's not everybody can play whatever he wants. That is cacophony. That is catastrophe. So you have this kind of rules. So everybody in the band knows exactly what is the form. For example, what are the harmonies? So you have a structure. But inside the structure, everybody who is improvising has the freedom to express in the second. That's a great balance between regulation and also freedom, right?
Yeah. Yeah, I mean, we in the microservice world, we have something called the macro architecture and the micro architecture. And the macro architecture basically defines the rules you have to apply. Yeah.
Right.
Alex looks like he wants to say something about it.
No, I was just reading a comment from Simon Harrer earlier today.
Okay.
It's couldn't agree more.
Yeah, I look at this actually more like a zoo, right? It's if your business is large enough, I think it's a trap to strive for too much order. It's you have very different demands and very different requirements and cultures that you have in a very large org. And if you're trying to set rules for everybody, there's a good chance it will kind of only fit for half of it.
Yeah.
And so I think building in microservice governance and in data governance, giving enough freedom for adjustment is something to consider. Also with regards to innovation speed. I think we are at a time where I think that in the LLM world, at least, or AI world, speed to market, experimentation speed is, I think, the most important thing you have to enable. And the biggest slowdown on a lot of this kind of greenfield experimentation projects are governance rules that you kind of have to have before you can touch certain things, move stuff to production, and so on. So, I think a lot about how can we balance this? How can you allow this iteration? How can you kind of give flexibility to different bits of the business? And at the same time, you don't want the crazy, and if you are not having enough, nobody can talk to each other. So you get crazy slow because of incompatibilities.
That's exactly what I was looking at.
Exactly what you're saying, Heinrich. As you said in the beginning, you cannot regulate everything and every detail. At data mesh, there's another very important principle. That's what we call federated governance. And that is like a state, like a democracy. You don't manage everything on the same level.
Yeah.
You have some fundamental things you manage on the top level. That is valid for everybody. But on the lower level, you manage more in another granularity, more details, like on a state or in a city or in a household, right? You manage different things.
I love that picture.
Yeah. You manage the general interfaces, how things are supposed to play together. And
guidelines,
the individual parts have
you manage
detail.
on a high level, but the details, how you move bits and bytes and what does it mean, maybe on a domain level, right? Or even on a data product level.
Getting back to your picture, Heinrich, I was actually looking for these data governance rules where you say better not mix the lions and the giraffes because it won't play out well.
Yeah, or maybe a cultural mixture. I mean,
I'm not sure, but I don't know. Are there any such rules, Christoph, where you say, well, that's never a great idea?
Probably. Nothing comes to my mind at the moment.
Too distracted from the picture of the lions.
I would say the human rights of data, probably, right? there's probably some principles you should never do, but I don't know at the moment, to be honest, right?
Okay. No, I need to laugh because we were discussing architecture principles the other day, and I referred to the Charter of Human Rights in terms of don't
data.
Yeah.
Yeah, there's some parallels maybe.
Yeah. But looking at architecture principles, in software architecture, we don't call it. I've never heard the term federated architecture governance, but we have the subsidiarity. I hope I say it correctly. Subsidiarity. I think that's the correct pronouncement, and it means exactly that. You manage. You have rules on different levels. Yeah.
Yeah.
So you always want to have to make the decisions on the lowest possible layer. That's the idea, but some decisions have to be made on the top. Yeah.
Right.
Yeah,
I think now is a great time to jump into DuckDB and get your take on local data processing.
Yeah. So I'm not an expert on DuckDB, but it's as you said, it's a completely different paradigm, which is coming up here, and it's a great product. All what I saw, it's amazing. Also the performance, the speed, and how this was developed, it's great. I see impact in the industry or with other people, and as you said, it's very local. It's on a single server. It's even on your laptop. It's a complete different paradigm. There you're not running on a cloud server somewhere centralized with a lot of users. You have your own stuff. You can save money with this. I think that the biggest challenge is probably, again, the governance. How do you manage that, right? It's kind of bring your own device or bring your own database or your own DuckDB, but still in an organization, it has to be managed in some way. So what is allowed, what is not allowed? Where do you get your data from? Where you store your data? Right? Is it just on your laptop and your laptop gets stolen? Do you have to, I don't know, safeguard it somewhere, versioning? So there are millions of questions, which I don't know how to solve that.
I mean, did we, when Heinrich mentioned DuckDB first, did we clarify briefly what DuckDB is?
Yeah, I think we should do that. So, I mean, my experience with it is really as a CLI tool and as a Python library. So, for a long time, like, how do you have your source data available, right? It's a bunch of like ZSFile JSON files or like Parquet files living in folders. And for a long time, I've been looking for a tool where I can just say, treat this as a database and let me load this stuff and do SQL queries on top of this. And this is exactly what DuckDB allows you to do. So instead of kind of loading all those things into memory, then putting it into an SQLite with an ETL thing, and then you do the SQL, you can kind of import this as virtual tables, or they are just automatically discovered and loaded into a namespace. So you get an experience. You have directly a SQL-like query interface to just stuff that lies set out on the file system. And from that, it's kind of a local toy, right? It's a command line tool that allows you to be productive. It can be like replace some of the pandas magic you might do in Python, also without loading stuff to memory. So it has performance aspects to it. But it also reminded me of like systems like Presto SQL that are like a federated query layer on top of different data stores where you just like query all of this. And I think I read some Hacker News articles that this is kind of has a trajectory in the kind of data architecture space where you would kind of either use the tool or ideas to kind of cross over. But it may be not really something, but the basic idea behind the tool is as I just described.
Yeah.
Right?
And I think the biggest advantage is it's very simple and it's easy and it's fast, right? And of course, end users might ask, why do I have to build a data product and use this standardized environment of my organization and do all this hassle until I get my results? Why not just dumping the data on my laptop and doing my DuckDB magic and pandas, easy little Python script, and I'm there. Much faster, easier, I'm more flexible. but it also has a lot of challenges. So we talked about data lineage, right? Data governance, all this stuff. How can you make this sure?
Nothing.
Yeah, it's a different approach. I would say it's a paradigm shift, right?
Yeah, I don't know if I want to explore this avenue, but like one striking experience was just lately crunching some data, doing that in Presto and querying a data lake. It took like 3 minutes, quick query. Mm-hmm. And then the entirety of the data sets I was working with was maybe 10 gigabyte. Mm-hmm. So pulling that down to the file system first and then working with DuckDB was just orders of magnitude faster.
Exactly.
And the queries actually looked the same, but just with minor translations, right? And also building applications on the query side and the reporting side on top of the data lake always ran into this problem of the query on the data lake is actually too slow. So you need kind of a hot version of that data set that lives somewhere. And I mean, I don't claim I'm an expert, but this is the wall I'm running against often. And I know that there's kind of data reporting systems that have some hot loading capabilities, but this is something where I could see like a system like DuckDB Shine that they kind of allow you to, it's not out of the box functionality, but I could imagine a system that kind of does the persistent caching for you in a similar way. Yeah.
Mm-hmm. Mm-hmm. Or for departments who are doing innovation, who are moving very fast, trying things out with data, maybe that is the right tool for them to be super flexible, super fast, but maybe not for production grade data management.
Is there something in Databricks that allows you to kind of cache data sets from the data lake for more local processing?
As far as I know, no. We even work with DuckDB. I think we have an interface. You can even integrate this into the Unity catalog, but I don't know the details about it.
Okay.
I think we had more than 100 very interesting minutes. Christoph, thank you very much for taking the time, for answering all the questions.
Thanks a lot, Christoph. It was really great.
Thank you.
Enjoyed it very much.
That is my secret. Instead of reading papers, I just ask Christoph all the questions.
It's a way. I really enjoyed the conversation with you guys, and big fan of this CaSE podcast. So I'm very, very happy to also be part of this now. Thank you for your time and setting this up and organizing this. And yeah, it was a pleasure talking to you. Thank you.
Yeah, and maybe so one more thing. When I mean, not a question. It's just a conversation I had with Christoph. We both live in Cologne, so we met for a lunch and we talked about this podcast. And also, Christoph, he also said he can come to yet another episode later this year where we talk about interesting AI use cases, which we didn't touch that much today. Mm-hmm. But we can, then let's see what we can do in the second or third quarter.
And maybe then as an on-site recording?
Sorry?
I said maybe as an on-site recording, because we were talking about having an on-site recording once, maybe.
I'm open to that, absolutely. So I'm happy also to talk about this topic. That's kind of my heart blood is in that. And hey, at Databricks, of course, we see a lot of examples how customers now using Gen AI use cases, what they are doing, and what is the status. And as I said, the development is so fast. It's crazy, right? It's very, very fascinating.
All right. Then I would say thank you very much and see you next time on exciting AI use cases.
Thank you very much for having me.
Have a nice also evening. For all the listeners, thank you for making it so far.
Thank you.
Hope you enjoyed the show. Bye.
Bye.